What do you call a crushed square? A rectangle. A rectangle. All right, boys, girls, welcome to video lesson 11-4, our lesson on regular polygons. Okay, the definition of a regular polygon you already know, but it's a polygon where all interior angles, and all sides are congruent. So looking down here, this is a regular hexagon because it has 6 sides, and every regular polygon has a center, which we're going to call, in this case it could be a P or an O, but whatever point this is the center of the polygon. In this picture right here, we have a regular hexagon still, and drawn around the hexagon there is a blue circle. This blue circle is circumscribed about the hexagon, and if you want, the hexagon is inscribed in circle P. If this point right here is P. So the hexagon is inside, so it's inscribed the circle. The circle is outside the hexagon, so the circle is circumscribed about the hexagon. In this picture right here, we now have a red circle. It's a little smaller than the blue circle, but the red circle is inside the hexagon. So the circle is inscribed in the hexagon, and the hexagon is outside of the circle, so it is circumscribed about the circle. So if you want to think about it this way, every regular hexagon, every regular polygon, or every regular anything, every regular polygon, in this case a hexagon, has an inscribed circle, and it has a circumscribed circle. And if you want to think about it this way, every circle is going to have an inscribed regular polygon and a circumscribed regular polygon. So we can continue drawing hexagons and circles forever. Okay, a couple more words you need to know. The radius of a regular polygon. The radius of a regular polygon is a segment joining the center of the circle, circumscribing the polygon to any vertex of the polygon. So I can draw a radius from the center of my circle to any vertex in my polygon. So there is a radius. Here is a second radius right here drawn to the vertex of the polygon. You can see now that all radii are congruent to each other. They bisect the angle of the regular polygon. So in other words, this angle is congruent to this angle. This angle right here is cut in half by the radius. And the radius of a polygon is also the radius of the circle that's circumscribed about the hexagon. Okay, another word you need to know is the apothem of a regular polygon. That's an apothem, not an apothem. An apothem is an animal. I was driving down the road the other day, and all right, never mind. So an apothem, not an apothem, an apothem of a regular polygon is a segment joining the center of the polygon to the midpoint of any side. So in red here, I can draw an apothem from the center of the polygon down to the midpoint of one of my sides to my hexagon. Here would be a second apothem. Okay, just like the radii, they have a bunch of things in common. All apothems are congruent to each other in a regular polygon. The apothem is the perpendicular bisector of the sides of the polygon. So this thing right here is perpendicular to the side, and it cuts the side in half. So this side is equal to this side. That's a right angle right here. Okay? And the apothem is the radius of the inscribed circle. So we can see now that the apothem is the radius of the circle that's drawn inside my hexagon. Okay, one more word you need to know, the central angle. I guess two more words, one more definition. The central angle of a regular polygon has a vertex at the center of the polygon, and the sides of my angle are the radii, so drawn to the vertices of my polygon. So here are my radii. This is my central angle right here. Okay, the degree measure of the central angle is always going to be 360 divided by n, where n is the number of sides in the polygon. That's important to remember, and it's easy to remember because in this case, this is a hexagon. So I already know that my measure is going to be 360. divided by 6, because I have I have 6 sides, so my n is 6. 360 divided by 6, the measure of each of those angles is 60. And I know that I'm going to have 6 because if you look at my polygon, if I chop it up and draw all my radii, you can see now I'm going to have 1, 2, 3, 4, 5, 6. I have 6 central angles that go around the whole circle, which of course is 360. So however number of sides I have in my polygon, that's the number of central angles I'm going to have in my complete circle. So it's 360 divided by n. Okay, we'll go over this formula in class, but the formula for any regular polygon for its area is equal to 1/2 a, which is my apothem, not my apothem and not my apothem, times the perimeter of the regular polygon. And we'll derive this formula in class. It's actually really simple, and it's an easy formula to remember. But the area of a regular polygon equals 1/2 AP. So if I look at this problem right here, furniture, the top of the table shown is a regular hexagon with a side length of 3 and an apothem of approximately 1.7 feet. What is the area of the tabletop to the nearest tenth? So I'm going to use my formula. Area equals 1/2 AP. In this case, 1/2 is 1/2. My apothem is 1.7. And my perimeter, each side is 3. I have 6 sides, so therefore 3 times 6, my perimeter is 18. I'm going to whip out my little mini blue calc and do 1/2 times 1.7 times 18, and I get 15.3. The area of that table is approximately 15.3. Okay, find the area of a regular pentagon with a radius of 5 centimeters. So we can see now in our picture, oh, wrong button, sorry. In our picture here, now I have a radius of 5. I want to know the area of my regular pentagon. So I'm going to use the formula A equals 1/2 A for area, little a, which is my apothem, times my perimeter, which is going to be 5 times the length of each side, and of course I have 5 sides. So I am missing both my apothem. I don't know my apothem. My apothem would be this in red right here. That's my apothem. And I don't know the length of my side right here, which would be in blue. So we're going to have to go through what are my steps to finding the area of this regular pentagon when I don't know my apothem and I don't know my perimeter. First thing I'm going to do is I'm going to draw in my 2 radii to find my central angle. In this case, my central angle is going to be 360 divided by 5, which equals 72. That's my central angle. That's this angle right here. And now we can see, what does my apothem do to that central angle? It chops it in half. So this little angle right here is going to be half of 72, which is 36. Okay, so we just chopped our central angle in half, and this piece right here was 36 degrees. Half of 72, so I know right now that this is 36. Okay, and I knew that my length of my hypotenuse here of this right triangle is going to be 5, and I need both my apothem and I need the base of my right triangle right here. We'll call that B. So I need to use trig right now. I need to use trig to find both of those. So I'm going to find first. Let's find my B. My B, I'm going to use sine, cosine, or tan. You guys tell me. Sine, cosine, or tan. Very good. We need to use sine because I know now that the sine of 36 degrees is going to equal B over 5. And now to find my A, let me change colors. Sine, cosine, or tan. Very good. We're going to use cosine. I know that cosine of 36 degrees is going to equal my adjacent, which in this case is A, over 5, my hypotenuse. Go ahead, whip out your calcs, and find for me both B and A. I'll come right back. I'm going to go find an apothegm. Okay, what I did to find my B, I multiplied both sides by 5, so B equals, this is Back in Black, B equals, that's a song by AC/DC, Back in Black. B equals 5 times sine of 36 degrees, and I found that my answer was 2.94. And I'm going to go at least a couple decimal places because I don't know how accurate I need to be. But remember, we need to round to more places than what we need to be accurate to, and we'll talk about that in class as well. And I'm going to find my cosine now. You should have taken A. A equals 5 times cosine of 36 degrees. And you found that A was 4.05-ish. Okay, we're going to now use our formula to find the area. This area equals 1/2 AP. So that equals now 1/2 times my apothem. I think I found my apothem to be 4.04. That was this piece right here, 4.04, my apothem. And I also found my base. Remember, I found my B. That was just this little piece. That was 2.88. I'm sorry, it was 2.94. But now to find the base of my triangle, I know I need to take that and multiply by 2. So this thing would be 5.88. And now I'm going to take that and multiply by 1, 2, 3, 4, 5. It's a pentagon, I have 5 sides. So I need to multiply 5.88 times 5. And that's going to equal my perimeter, which is 29.4. So now my area is going to equal 1/2, I'm pulling out my little blue calculator, times 4.04 times 29.4. And I have an area of approximately 50.4. Smiley face. Okay, let's do one more. We'll do this one a little bit quicker here. Okay, I want to find the area of a regular octagon. And again, I know I need trig. An octagon is not one of our 3 specials. Our 3 specials were either a triangle, a quadrilateral, or a hexagon. All other regular polygons, we need to use trig to find the apothem. So I know I have a regular octagon with a side of 12. We can see the side of my 12 is right here. Just because I like to look down at the bottom, I'm going to draw my triangle down here on the bottom. Okay, I know that this side is 12. First thing I need to do is I need to find my central angle. My central angle is going to be 360 divided by 8, which equals 45. So I know that my central angle right here is 45 degrees. Okay, so if I draw my other radius here in my next picture, I knew that my central angle was 45 degrees, so now half of that is going to be half of 45. So I know that this little angle is 22.5. And I knew that my base now, my total base of my triangle, the big triangle, if I think about the whole thing, was 12. So just half of it is going to be a length of 6. Okay, so we only need now to find the length of the apothem. I know my base. I know my base already is 6. So I can use trig. I can use trig to find this one out. You guys tell me real quick, do I use sine, cosine, or tan? Play this game. I love this game. So katoa. Sine, cosine, or tan. What's your answer? Quickly. Yes, the answer is tan because I have my opposite. I'm looking for my adjacent. So I now know that tan of 22.5 is equal to 6 over A. Therefore, doing my cross multiplication, A is going to equal 6 over tan of 22.5. Go ahead and whip out your calcs. Let's figure out what that is, and I'll whip out mine too. I'll be right back. Okay, so I found my altitude, and I hope you did too, my apothem, to be approximately 14.49, or even very close to 14.5. But if I want to find the area of my regular octagon now, I'm going to do 1/2 times my apothem, which is 14.49, times my perimeter, which is going to be 8 times 12. Because I have 8 sides, all with a length of 12. 8 times 12, don't tell me, is 96. So I'm going to whip out my calc right now and do 14.49 times 1/2 times 96, and I get approximately 695.3. That's it, folks. Have a great day, and we shall see you soon.